Here we are figuring out the relationship between naive Bayes, which is a generative method, and logistic regression, which is a discriminative method. So let's start by writing the classifier version of the naive Bayes classifier. So basically y is 1, given x1 is x1, x2 is x2, and xm is xm. So the first step is, because when we train a naive Bayes network, we are training the other conditional distribution, which is x given y. So we need to write in terms of those first. So start by using the conditional probability definition, which the conditional distribution is just the joint, say x is x, divided by the marginal, which is just x equal to x. So then the next step is, as I said, we have the other one. So we only have x is x given y is 1. So we are going to write the joint in terms of this. Then you need to multiply it by the other marginal, y is 1, and divide it by, on the bottom, this is basically the marginal distribution by marginalizing y out. So it's basically x is x, y is 1, plus x is x, y is 0. So both of these terms can be written in this form. So let's write it. This is, the first term is given y is 1 times y is 1. The second term is the same thing except for y is 0. Y is 0. Okay. So next we want it in the form of the logistic function, so we probably should divide by this whole thing. So let this whole thing be, say, p. You divide p on the bottom and on the top, and it will be 1 on the top because it's p divided by p. On the bottom is, this, again, p divided by p. So it's 1 plus this whole thing divided by p. And this is x, given y is 0. Probability y is 0 divided by x is x. Sorry. Y is 1. Probability y is 1. And we also wanted that exponential, so let's just directly add the exponential there, but exponential of log is going back to the original thing. So basically here we're using exponential of log of, say, some any x, it's just x. And then we need to rearrange this somehow so that it looks like the logistic function. So we need to use the fact that log, say, a over b is just log a minus log b, and log a times b is log a plus log b. So if you expand this and then put it back in an organized way, it's just minus log probability y is 1 over y is 0 minus log probability of x is x given y is 1 divided by probability of x is x given y is 0. So at this step, it looks like logistic function already, and this will be b. And remember, b is independent of x, so, and this term is independent of x, so it's okay. And then this thing looks like x transpose w, which is dependent on x. And so this looks like the activation basically looks like the probability of y is 1 given x is x for our logistic regression.